Hi guys, today I'm going to walk you through some examples of how to find the greatest common factor of a set of monomials. So let's start just with a reminder of what the monomials themselves are. So the two I'm going to give you right now are 12, x to the third, y to the second, and 44, x, y to the third. And I'm going to remind you that a monomial, the reason these are called monomials, remember mono means one, and each of these polynomials is just made up of one individual term. So that's why these are monomials. And we're going to find the greatest common factor of that. So remember from previous videos that factoring means that this is not a very mathy term, but we're going to pull them apart into the little pieces that make them up. So let me kind of show you what I mean by factoring by showing you step one. We're going to do what's called fully factoring. So we're going to pull apart these two monomials into the little pieces that we had to multiply to get it. So for example, you could get a 12, I'll look at that part of it first, by doing 2 times 6, because 2 is a prime number. That means that I have factored 2 as much as I possibly can. So now I'm going to turn my attention to the 6, but I know that I can factor the 6 further, right? Because I can multiply 2 times 3 to get 6. So now I have a 2, I have a 2, and I have a 3. Those are all prime numbers. So I know that that's the fully factored version of 12. So 2 times 2 times 3. Now I'm going to turn my attention to this x to the third power. So x to the third is just another way of saying x times itself 3 times, right? Hence the exponent of 3. So the fully factored version of x to the third, if we pull that x to the third apart, is just going to be an x times x times x. So that is going to go with the next part of my fully factored form. And then, of course, y to the second power is just another way of saying y times itself twice. So if I factor it, if I pull that apart, it would be y times y. So I've got the fully factored version of 12 x to the third, y to the second. So I also need to fully factor the 44 xy to the third. So 44, I can multiply 2 times 22. Obviously, the 2 is now prime, so that's as factored as it's going to get. So now let me turn my attention to here. So I can get 22 by multiplying 2 times 11. And now 2 to 11, I have all prime numbers. So that's the fully factored form of 44. Whenever you have a variable and it doesn't have an exponent, there's technically an understood 1 there that we just don't write. So the fully factored version of x, you can't factor x any more than it already is. So I'm just going to bring that down. And finally, y to the third would be the same as y times y times y. So now I have my fully factored form. So I've got the fully factored form. I've just done step 1 of those of the process. My next step is to find common factors. So in other words, what do these two have in common? What are the factors that they share? So I see that this one has a 2 and that one also has a 2. This one has another 2 and that one has a 2. This one has a 3, but the other one does not have a 3. So remember, we're only finding what they have in common. This one has an 11, but of course the other one doesn't. So again, it's just got to be what they have in common. But we do have an x, right? Each of them does have an x. Even though this one has a couple more x's, we're only, again, looking for what they have in common. So we're just going to underline one of the x's. And then finally, we have 2 y's. And this one also, it has 3 y's. But again, we're only going to underline what they have in common. So then finally, our last step is to multiply those common factors to get the GCF. So we're going to multiply. What did they have in common? So they each had a 2. They each had another 2. They each had an x. And they each had 2 y's in common. So we're going to multiply all of that together. And that means the greatest common factor is 4x y to the second. So that, my friends, is the GCF. It's important that you need to note, because this is a very common mistake a lot of people make. They think that they need to take, because it kind of looks like there's 2 sets, right? This is something that people do wrong a lot. They take and I'm writing this in red because this is incorrect, okay? So again, right now, this is wrong. A lot of people go, okay, well, I have a 2 and a 2 and an X and a Y and a Y. And then I have another 2 and a 2 and an X and a Y and a Y. And then they multiply it all twice. That is not what you do, okay? You're only multiplying one set. You're just finding, what is the one set that they both have in common. Okay, so let's try another example. If you want, you could go ahead and pause the video and try to work it yourself if you wanted to. I think that would be a great idea. Or if you want to stick around and do this one with me, you can. So remember that your first step is for each of these monomials, you need to fully factor it. So I'm looking at the 72, and I know that I can multiply 2 times 36. And that 2 is prime, but I can factor the 36 apart into 2 times 18. Now I have a prime number here, but I can still factor that 18 down more to 2 times 9. Got another prime number now. And then finally the 9 can be factored into 3 times 3. I'm finally down to all prime numbers. So that'll be 2 times 2 times 2 times 3 times 3 gives me that fully factored version. So I took that 72, I factored it apart. R to the second is going to be the same thing as R times itself twice. So that's going to be R times R. And K to the second power also means K times itself twice. So the fully factored will be a K times K. So now let me factor the other monomial. So 36, we're going to get 2 times 18. We kind of already did this one, right? 2 is prime. So now I've got 2 times 9. And once again, I'm going to factor it into 3 times 3. So the fully factored form of 36 is going to be 2 times 2 times 3 times 3. There's only one R there. So the fully factored form of R is, of course, just going to be R. And then K to the third is the same thing as K times itself 3 times. So the fully factored form will be K times K times K. So step 1, I fully factored them. Step 2, let's find out what they have in common. So we've got a 2, another 2, a 3, and another 3. We've got just one R, because we only have one R over there. And we have a K and another K. So we've got 2 times 2 times 3 times 3 times R times K times K. So we're going to that's everything that they have in common. We're going to multiply all that together. So 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. And we've got an R and then a K to the second power. So the greatest common factor of those two binomials is 36 R K to the second power. Okay guys, how about you try this one yourselves? You can pause the video and then try it out if you want. I'm going to assume that you already did that part, and I'm going to go ahead and fully factor this to start. So I know for the 18, I can do 2 times 9. That is a prime number. Then I can factor this into 3 times 3. So I've got 2 times 3 times 3. I've got a single x, so the fully factored form is just going to be x, and p to the second is going to be p times p. And then for the next one, the 48 can factor into 2 times 24. Then I can factor the 24 into 2 times 12. Then I can factor that 12 into 3 times 4. 3 is prime. And finally, the 4 will factor into 2 and 2. So the fully factored form of 48 is 2 times 2 times 2 times 2 times 3. Typically, when we do the fully factored version of something, we write it in order from least to greatest. Doesn't really matter, I mean, in the grand scheme of things, but it's just what we have a tendency to do. And then x to the fourth is just going to be x times x times x times x. So I've got them fully factored. Now let's see what they have in common. 2 and 2. I've got a 3 and a 3. There's an x that we can factor out of both of them. And that's it, right? Because this one has p's, but the other does not have p's. So 2 times 3 times x gives us our greatest common factor of 6x.